Okay, so this circuit one is given. We don't know what is inside that, but we know it's a circuit. And we have the terminals A and B, terminal A and B. And the problem says we have measured the open circuit voltage of the circuit as the open circuit 6 volt. Okay, so you look at this potential when it's open circuit. So V of open circuit is 6 volt. Next, we connect a resistor R1 10 ohm to this terminal, and the voltage across that is measured as 3 volts. Okay, so now the problem wants us to find the Thevenin equivalent. Okay, so when we see V of open circuit or I short circuit, that somehow can remind us about the Thevenin or Norton equivalent. So in this case, because it's a V open circuit, we can think of a Thevenin equivalent. So we can say, okay, the circuit one, we can consider this Thevenin equivalent as a voltage source with Thevenin in series with a resistor, which is R Thevenin. Now in this case, because it says the V open source is 6 volt, therefore V Thevenin is 6 volt. Okay. So this is the second one. So this is what is, the equivalent of what is inside circuit one. Now it says, now I connect this to a 10 ohm resistor. Okay, so I connect this to a 10 ohm resistor. And now the voltage here will drop to 3 volts. Okay, so it's 3 volt here. And we need to find R Thevenin because it says eventually find the Thevenin equivalent. Okay, so as you can see, there's 6 volt here, some resistors, and there's the voltage here. So this looks like a voltage division, right? You have a voltage, you have 2 resistors in series. So I write the voltage division formula. You can do, or we can find the current, or like whatever you want to do. So I prefer to do this. So the voltage across this 10 ohm is 3 volt. So this 3 volt is basically 10 divided by 10 plus R Thevenin times the V Thevenin here, which is 6 volt. Okay, and from that you can easily find the R Thevenin. So multiply 30 plus 3R Thevenin equal to 60. So 3R Thevenin is equal to 30, and R Thevenin is 10 ohm. Okay. Very good. So you could also do this. You can say, okay, this is 3 volt and this is 10 ohm. So you find the current here. So the current would be 3 divided by 10. That's this amp. And then you could do basically a KVL. We could do easily a KVL here. That, okay, if this is the current 0.3 amp, so minus 6 plus R Thevenin times 0.3 plus 3 equal to 0, and then R Thevenin would be 10 volts. Okay, however you prefer to do that. Okay, so okay, at the end, so if you want to draw the equivalent Thevenin equivalent, so V Thevenin was 6 volt, as we knew, and R Thevenin is 10 ohm, and this is terminal A and B.